Okay, this is going to be a quick introduction to the law of conservation of mass and balancing equations. First, the law of conservation of mass. One thing you need to understand is the word conservation means to preserve or to keep. So in this case, we're going to be preserving or keeping the mass. And of course, we're going to be talking in chemical reactions and chemical equations. The first part of this is that matter is neither created nor destroyed, which means we can't just have atoms and molecules suddenly appear or disappear. They have to come from somewhere or go to somewhere. So remember that a chemical reaction is when the atoms in substances rearrange to form new substances or different substances. The second part, because we are conserving the mass, is the mass of the products must equal the mass of the reactant. So whatever mass we have at the end, we have to have it in the beginning. It doesn't just disappear. And the last little bit to kind of help, and this was more for the balancing part of the law of conservation of mass, is that the number of atoms on the reactant side is equal to the number of atoms on the product side. And it has to be the same type of atom. So if we have 2 carbon atoms and 1 oxygen atom, but then 2 oxygen atoms and 1 carbon atom, technically it's the same amount of atoms, but they also have to be the same type of element. So if we look at this first example, we have hydrogen reacting with oxygen and producing water. So we need to ask ourselves, does this equation follow the law of conservation of mass? There are 2 things that we can do, and one I really use a lot is just setting up a chart where I look at my reactants, and I'm just going to put an R, and I look at my products, so a P. And then I look at the atoms that I have in the equation. So I have hydrogen and I have oxygen. Okay. And all I'm going to do is I'm going to count how many atoms I have on the reactant side and how many atoms I have on the product side for each element. So if you remember, these little numbers here are called subscripts. And a subscript tells us how many of each element there are. So for hydrogen, it has a subscript of 2 on the reactant side. Remember, the reactant side is what we start with. So we have 2 hydrogens. Oxygen also has a subscript of 2, which means we also have 2 oxygens. Okay. Now if I look at my product side, remember product is what we end up with, so I end up with water. I also have 2 hydrogens. And since there's no subscript after oxygen, that means that we have 1 oxygen. So if you're looking at this, it's quite evident that we do not follow the law of conservation of mass because we don't have the same number of atoms. If we were to look at a picture of this, we could say it would be like this. So we have our hydrogen here, our oxygen here, and then our water as our product. And if you notice, one of the oxygens just disappears. Well, according to the law of conservation of mass, that can't happen. It can't just disappear. So now we have to go and figure out, well, how can we balance this equation so that we have the same number of oxygens on the reactant side and the product side? So there's a couple of things that a lot of people want to do right away. So they'll say, oh, well, I just need another oxygen, so I'll just put a 2, a subscript of a 2. And then I'll have 2 oxygens on the product side, 2 oxygens on the reactant side, and I'll be good. However, you cannot change subscripts. This changes what the compound is, so we cannot do this. In fact, H2O2 is hydrogen peroxide, and if you drank enough of it, it would kill you. So, cannot add subscripts. It changes compounds. Never do that. So then the next option that a lot of people have is, well, what if I just add another oxygen? So now I have 2 oxygens on the product side, 2 oxygens on the hydrogen side, or on the reactant side. Again, can't do this. This changes the equation. In the equation, we only have hydrogen and oxygen and water, an oxygen molecule. So we can't just randomly add more things. We got to work with what we have. So the only thing we can do is add coefficients. Coefficients, if you remember from math, go in front of things and they act like multipliers. Oh, I'm pressing all sorts of buttons. So they act like multipliers. And what this does is it changes the amount of molecules that we have in the compound. So I'll obviously work this one out with you. I'm going to set I call it a T chart, back up. So I have hydrogen and oxygen. I have 2, 2. On the product side, I had 2 and 1. Okay, so a coefficient, just like in math, goes in front of things. For example, if we have 2x, this lets us know that there are 2 x's. Okay, so I look at where I'm lacking. I'm lacking in the oxygen on the product side. So I cannot put a 2 right in between that because it's got to go in front. So I'm going to put a 2 in front of the H2O. Please excuse the handwriting. So when I put a 2 in front of the H2O, this now means I have 2 water molecules. So technically now I have, let me get a different color. So now this means I have H2O and H2O. So this 2 tells me I just have 2 H2Os. Now if we're realizing this, well now I have 2 oxygens. Okay. Another way you can look at it is the 2 acts like a multiplier. So there's 1 oxygen in H2O. We have 2 H2Os, so now we have 2 oxygens. But you might also notice now our hydrogens have changed as well. Since we put this coefficient of 2 here, now we also have 2 times the 2 initial, 2 times 2, so now I have 4 hydrogens. Well, now my hydrogens are off, but on the reactant side. So hopefully you guys recognize that, hey, what if we just add a 2 over here? If we put a coefficient of 2 in front of H2, again, that shows that we have 2 hydrogen molecules. So we have H2 and H2, which would be a total of 4 hydrogen atoms. Now, if we're looking at this, we have 4 hydrogen atoms on the reactant side, 4 hydrogen atoms on the product side, 2 oxygen atoms on the reactant side, 2 oxygen atoms on the product side. Now we are a balanced equation. And if you want to see a picture of this, it's depicted here. 2H2 plus O2 gives you 2H2O. So that shows we have 2 hydrogen molecules, 1 oxygen molecule, and then 2 water molecules. That's what these numbers will tell us. So keep in mind, just like when we were working with formulas, if there is no number, that just means it's a 1. But just like when we were working with molecules, we don't actually have to write the 1. So we'll do one more example just to kind of hopefully help you out. So we have N2 plus H2 gives us NH3. So I'm going to start with my T chart, reactants, products. The atoms that I have here are nitrogen and hydrogen. If I look on my reactant side, I have 2 nitrogens and I also have 2 hydrogens. On my product side, I have 1 nitrogen and 3 hydrogens. Now looking at these, it's not easy to multiply 2 to get to 3, but I have 1 nitrogen on the product side, 2 nitrogens on the reactant side, so that's where I'm going to focus first. Okay, so I have 1 here, I need to get to 2. So if I put a 2 up here, that multiplies in this 1. Now I have 2 nitrogens. But this 2 also goes for hydrogen. So now I have 2 times these 3 hydrogens. So I have a total of 6 hydrogens on the product side. Looking at the reactant side, I only have 2 hydrogens. So I need to think, what can I multiply this 2 by to get to 6? And hopefully you guys are good in 3rd grade math. So I put a 3 right there. 3 times 2 gives me 6 hydrogens. And now we are balanced. So this, if I can move it, there we go, would be how nitrogen and hydrogen react to produce nitrogen trihydride or ammonia. I have 1 nitrogen molecule and I have 3 hydrogen molecules, and this produces 2 ammonia molecules, NH3s. And so if we were to actually count the atoms, I'd have 1, 2, 3, 4, 5, 6 hydrogens, 1, 2, 3, 4, 5, 6 hydrogens, 1, 2 nitrogens, 1, 2 nitrogens, and it's a balanced equation. One key thing to remember when you're balancing equations, it's a lot of trial and error. If you don't get it right the first time, just keep going. Try something else. Try a different coefficient. It will eventually work out.